Okay, so let me explain the Newton method and the Mueller method. So first of all, let us see the Newton method. We got the formula at there, which is x base n plus 1 equals to x base n minus fx divided by f prime x. Okay, so first of all, let us set our x naught, which is 5, and then using the calculation of the fx, which is our equation is x cubed minus 13x minus 12. So I get 48, and my differentiation will be 62, and I will get the 4.225806, which is from this formula. And I just replace the x1 become the x naught, and then I get the x2, x3, and also x4. So x4 we get the exact answer, which is 4. So this is our Newton method. Coming to the Mueller method, so we can see that uh, they use the step quite longer than the Newton method. So first of all, let us set because for the Mueller method, we need at least 3 points. So we use x0, x1, and x2, which is 3.5, and 4.5. So because we are using the h0, which is we're using the x1 minus x0, and then h1 equals to x2 minus x1. So we get these two answer, and then we got the delta 2, which is using the h0, using the fx2 minus the fx1, fx1 minus the fx0, and then divide by h0. So we get the delta O and delta 1. So we're using this format, four values, and then we're getting the A, B, C, D. So first of all, we're using the A first. The A is the delta 1 minus delta naught, and then divide by the combination of H1 plus H naught. So we're getting the A, and then the B is actually is the delta 1 plus delta H1, and then no A times H1 plus delta 1. So we get the B, and then also the C is actually C is the same value of the fx2. So the D is using this formula, which is B squared minus 4AC, and then we square it, and then we using the denominator, which is we're using the b plus square t, and then we get the x3, x3, which is using the formula. The formula is x2 minus the 2c divided by denominator. So, and then we repeat this one iteration until we get the exact value, which is 4. So this is from the example 1, we can see the difference between the Newton method and the Mueller method. So coming to the example 2, actually the example 2, we just combine we just using one equation, and then we got using only Mueller methods. So we using the three assumption, which is x1 equals to 0.5, x1 equals to 0.7, and also x2 equals to 0.8. And then we got the fx, which is x power 3 minus x times x power 2 plus 11x minus x. So we got the same fx, and then using just same equation, the same formula as just now. So we get the x3, and then until we get an exact value. So actually this is nearly to exact value. So if I continue to the x4, which is we will get the x3 equals to 1. So I just stop here because this also actually is nearest to 1. So this is, you can see from the different, because from this we got only one roots, and then this got three roots. So they can get the nearest root, which is 1. Yeah, the nearest root is to these 3 x. Okay, coming to the example 3, because the Mueller method is especially for the complex roots, so we can see that we're using three points, which is x1 equals to minus 1, x1 equals to 0, and then x2 equals to 1. So until we get the d equals to minus 3, because we are using the square root t, so the square root minus 3 is not in the real roots, there is imaginary roots. So they will show number, uh, there are errors from here. So that's why we are not using this this as the, because these are using the Mueller methods, so we are using some calculation in our website. Okay, so I'm not showing in Excel because they need some calculation by hand. Okay, coming to the application, this is a real world application which is using the some avoid to tragedy. Okay, so we got the data here, and then we get the, which is these are the two planes, the safe distance between two planes. So actually you can see that we got like a nearest answer from this x3, which is the answer is nearest to 18.757312, if not mistaken. Yeah, 1 1. Yeah. So actually this is not the same because this is 0 7 and then this end with 11. So after that we will get the exact value, which is 18.7573.11. Okay. So this is the three different function of the Mueller method, which the example one is different, the difference between two methods. The example two is we just using the one Mueller method, and then because we got 3 points, and then we see that the one Mueller method can let us get 1 point, what point. And then example three is because the Mueller method can using in the complex roots, which is the imaginary roots. So we are using the hand by hand calculation, so I'm not showing in the Excel. And the real world applications. So the real world application are using quite complex because our function will be x power 3 minus 2 5 or x squared plus 15,000 x minus 20,000, 200,000. So actually we got the unit, which is this is m. So this is the example of 1 2 3 4.